Oh, yeah. Welcome back, everyone, for another session of Vibe Coding with Waku. I am Chair. With me is Waku Research Engineer, SP. Hello, SP. How are you?
Hello. I'm great. You?
I am excellent. I'm pumped up. I'm ready. It is Monday. It is time to get cracking. This is part 2 of a stream that we started last week, that we hope to close out. If you, as the viewer, have any questions about anything that you see or hear during the stream, use the chat as a tool. We will see all discourse. We will respond as such and thusly.
Yes, I see the chat right there. I can see it right there.
We are live on Twitter and YouTube, wherever you are. If you could like and share and subscribe and retweet, FUD and comment and reply, it would help us greatly, and we do appreciate it. Looking to get more eyes on the wonderful technology that is Waku. Without further ado, I do pass it to SP. I will ask questions from time to time for my own clarity, and hopefully it'll be useful to others. But the car is yours, sir.
Thank you. I think we should just summarize what we did last time, right? For my own sake, yes. But if you have a question, share.
Well, let's start with what did we do last time?
So last time we had this to do, which was replace with Waku. That's a bit broad, but yes. Specifically, I wanted to use one of my older projects that used IPFS as a technology, but specifically the pop sub module in the Kubo implementation of IPFS. Sadly, that is now deprecated, but we can use Waku instead. So yes. So in
we're
the last episode,
ripping out IPFS and replacing with Waku.
Well, it's not the entire IPFS, but yeah, some part of it. So yes, last time we created this Waku handler, and we use the Waku Rust bindings. So basically, we have Waku handler. It has a Waku node inside and some kind of channel to receive CIDs for the video segments. So here we basically create a new Waku node via the bindings. So some config stuff, create a new object, set some...
Okay, some housekeeping on this. You are writing in Rust. You are using the Waku Rust bindings.
Yes.
And you are spinning up a Waku node to handle the transferring and communication of data as such.
Yes, indeed. Yeah, so we have to set some callbacks to get notified when Waku is receiving some messages. So that's what happened here. There's a bit of a couple different events, but mostly the one we're interested in is this one. So Waku event, Waku message, and then we should resolve this to do. By the way, that. But let's come back to it later. Down here, we subscribe to a topic. We have to do that to receive the messages on that topic, obviously. Then we have the start function. We start the Waku node. We print a nice string. The Waku is online. Hopefully, it's online by this point. But then there's a loop, and we just wait for video CIDs to get generated by the project, and then we call this function every time there's a new CID. And then when this channel is going to close, the loop is going to exit, and then we're going to print Waku is offline. We do some housekeeping. We stop the Waku node. We destroy it. I'm not sure exactly what's happening behind the scene when you call those functions, but it should work. I trust my colleagues that they did their job right. Last function, this is the on video CID. So when you receive a CID, you craft a new message. To craft a message, you need a content topic. We just create some kind of just a test content topic. And then the new message is just the CID. And then we publish it. Relay published message with our message on the topic. And then, yeah, that's pretty much what we did last time. So today...
Yeah, yes. What do we have to do now?
Yeah, that's a good question. I'm going to have to improvise because I did not prepare at all for this stream. I apologize. But I think the first thing we need to do is fix this. So
Yeah, we should not leak Waku stuff.
yeah, this architecture is an actor model. So all the Waku stuff lives in the Waku handler.rs, and then you don't want Waku stuff leaking out. So let's see what we can do. So we need to get Waku messages sent to another actor, the chatter, via a channel. So I guess we already have the channel here. Yes, okay. So when we create the Waku handler, we have to pass a channel that's going to handle Waku messages. So we're doing that. The thing is, we don't know what type of message it is. So it's kind of interesting, but I'm pretty sure it's a Waku message, this type. It should be fine. Should be fine. We're going to do just that. So the event, the Waku message in the event, we send the message via the sender. And then on the receiving end, this is the chatter actor. Did we change anything here last time? No, we did not. Oh, interesting. Okay, so we have a to do replace with Waku again. Previously, like I said, we used IPFS, so it's the pub sub module of IPFS we're replacing. So we have to do something about this, so that the chat system is online. So I'm thinking that we're just going to copy the chatter channel. We are going to add a new channel here. It is not going to be a transmitter this time. It's going to be a receiver. So is it a receiver? Yeah, bump in the receiver. Yes. Okay. So this, we have to pass that when we create it. So new. Then we add it here. And then we can use it in start. So we're not going to need that, but maybe it takes inspiration from it. Basically, it's the same thing as what we're doing here. So pretty sure we have to do this or something close to this. So it just go here. Okay, something like that. But this actor is different. You have two different stream. That's a ROS concept. Basically, you loop, and then you select one of the stream that's ready. So either you break the loop and shut down this actor, or you get the next element. So try next is trying to get the next element, and then you try to open the option. If there's something, you do on pops up message. So basically, we have to go from this to something that looks like this. So we don't need that. We're probably not going to need that. I'm thinking that probably video, it's not video receiver, it's chatter receiver. That's probably a stream already. So, I wonder if we can just do this, right? Then that would take care of. Do we need that? I'm not sure. We'll just comment it. Yeah, it seems like we can just do that. So try next. We're gonna match on it. This is a result inside the result there's an option and it pops a message. But it's in this case it's not going to be a pop some message, it's going to be a Waku message. So this type. So now if we go on this function, it's not going to be a pop some message, it's going to be a Waku message. But then we said to not leak Waku stuff. So I'm guessing
Among other things, it dawns on me that I need to learn Rust.
it's great. It's amazing. You should. But it's hard at first because it forces you to do things that you may not be used to. The rules are important in Rust. Yeah. So I'm thinking we're not gonna do the Waku message type just to not leak it. We probably want to check inside of Waku messages if I can. No, I can't check. Okay, that's bad. So here, basically, we would have to extract what we want from the Waku message and then use a channel to send that data instead of the entire Waku message. Probably just the payload, right? So extract the payload. Extract the payload. Yeah. So we would extract the payload, but then we need to know what's inside of Waku message. What if I do? Does that work? Maybe? If I do this, it's still unknown type. Huh, interesting. That doesn't happen often in Rust that you have a unknown type. Not sure why exactly. I'm also rusty in Rust because it's been some time since I used it. Yeah, why is it unknown? Interesting. I mean, if it compiles, that would. It doesn't matter if it compiles.
If it compiles, it compiles.
Yeah, if it compiles, it compiles. But
if it builds, it builds. If he dies, he dies.
But usually you need the correct type, otherwise, maybe it's just a vec of bytes. Probably. I'm not sure how else a payload would be implemented. So let's just do that. And then here, instead of Waku message, it's going to be... yeah, it's the same thing. It's a vec of... It's a vec of bytes. There you go. Okay. So this should technically work. Maybe there's a couple of errors that are related. Oh, okay. So those are actually, we have to fix that, otherwise it for sure not going to compile. So this is IPFS API DAG put, and it says expect 3 argument found 2. So you have to input codec store. Okay, so let's just do default and default because I don't know what that is exactly. I don't remember. Oh, it's the codec. Yeah, okay. The input code. Yes, okay. I remember. The name says it all. The input codec and the store codec. Okay, and then here DAG get. This is output codec we have to add. So default, nice. Not too hard to fix those errors. Input and store. Okay, the same thing. There you go. All right. Do we have other errors? Can I filter this by... This is an error. It has nothing to do with us, but where is that? Ooh. All right. Just gonna ignore that for right now. I don't know what that is. Maybe it's gonna fix itself. Hopefully. Probably not. Actually, no, it never does. It's all right. So that should take care of the leaks of the Waku outside of the Waku handler. Do we have other to do here? No. What about here? No. What about here? No. Okay, so all the to do we wrote at this in the first episode have been taken care of, so that's good. So now we just need to work our way to a functioning CLI, basically, because I don't think we added any setup code so that the Waku actor is started. Yeah, this is not needed anymore. And we have to set things up. This. Okay, so basically we won't have to do any of that. We have to go here, which is the CLI. In the daemon, we have the stream one. Would it be? Yes, the stream one is going to be the easiest to just start. Okay, what's happening when you call this? Okay, so do you IPFS peer ID? Interesting. You name resolves channel metadata. Okay. I'm just reading through this because it's been some time. I don't really remember how it works, sadly.
It should be noted that you're vibe coding raw, no LLM. So
Yeah. It's just, no AI, just good old organic coding. Yeah. So we see that here the archivist actor is set up, and then the videographer actor is set up here, and then we have we don't have the chatter or the Waku handler. Interesting. So, the chatter is supposed to be set up here. Okay, so that was commented. So we have to uncomment that for sure. And then we still have some errors. This is that get the output. It's going to be codec. Do we choose no codec? Default. Okay, I'm just going to use that and then do the same here to fix the errors. All right, so the output codec is default. Hopefully this works. Now, so the chatter actor is set up here, but this is wrong because we changed it. If you go back, when you call
Get that
new...
IPFS out of there.
Actually, no, IPFS is, you have to use it because you have to store some data.
You're still storing it somewhere.
Yeah.
Get that pub sub.
Yeah, we don't need that pub sub. We got Waku. Yeah, so we need to do chatter receiver. So this is the how would you call it? It's the channel that's going to go from Waku to the actor that's going to archive the chat messages, basically. So we need to set it up before. Let's do it here, I guess. Yeah. So here, so we have a receiver and a transmitter for the chat messages. So let's just say chat transmitter, and then chat receiver. This is going to be channel oh, you don't, yes, unbounded channel. You don't have to mention the type, because in Rust you can infer the type usually, which is great. Okay, so that's the receiver, that's a transmitter. So the receiver is going to go inside the chatter actor. You have to clone it. Maybe we have to clone it, maybe not. Anyway, just clone it. That's fine for now. And then the chatter transmitter, or they call it sender, is going to have to go inside the Waku handler actor. So let's create that. So handle maybe, and it's going to be, let's take inspiration from what's already there. You have to do, oh, okay. So it's just Waku handler equal Waku handler new. Then you have to fill this up somehow with all the things. Okay, so Waku handler new needs a chatter transmitter, a pops-up topic, and a video receiver. Okay, interesting. So this is needed. So this is the same thing as this, obviously. Topic, where do we get the topic from? From the CLI arguments, which we get where exactly? Where? Or maybe settings. Yes, I think, no, settings is where you would get the pub subtopic. Pretty sure. Video topic setting. Oops. Setting that video topic. Okay, that's what we need in our Waku handler. There you go. And then we need a video receiver. Video receiver. Where is that? Oh, it's here. Okay, that's a problem. So I guess I'm gonna need to create my Waku handler elsewhere, because in Rust, order matter. I mean, literally the where you put the code matters. Yeah, it's kind of weird, but it does matter. But function new is private. Oh, we can change that. Pub. There you go. Yay, it works. Okay. So now we have the Waku handler. It's gonna send chat received video. Wait, video data? No, that's not video data it's receiving. It's gonna be receiving CIDs. Okay, so that's a problem. Unbounded channel, video graph. It's because the videographer actually sends video data and not CIDs. So we have to check video. Let's go up. Video data. Maybe I've made a mistake. Yes, it's not video data. It's a Waku transmitter. Okay, so it's a new one. So you need a Waku transmitter. So it's not gonna be this. It's gonna be something else, and the video graph is gonna take a Waku, something like this. Wait, I'm confused. Okay, give me a second. So the Waku handler is receiving video CIDs. Okay. The video CIDs come from the videographer? Yeah. No. Do they? Wait. Let's check. The videographer receive video data. Okay. All right. Oh no, the videographer is responsible for minting video nodes. Yes. And then it sends. Oh, okay. So the videographer receives raw video data, and then it sends video CID to Waku. That's how it works. Okay. We don't need that. So I guess it goes here like this. So service. So service receiver is for video data. Archive transmitter is for archive, and then Waku is for receiving CIDs, right? Oh, that's not a receiver, that's a sender. Yeah, it's not the same thing. So from here we send. It's a transmitter. Yes. Okay. That was a problem. Okay, so the videographer is gonna send through this channel, and then Waku is gonna receive from this channel. So that works. This is defined This is defined somewhere, right? Right? No? Okay. Oh well, I guess we need to define that. Let's define it here, I guess. Chair, do you have questions so far? Am I making any sense or?
Yeah, when you start learning Rust, at what point is the furry character assigned to you, or is that something that you get to choose yourself? And then also, where do I get my socks? No, I'm kidding, of course. But I do have a plea to the audience. Please like and share and retweet and subscribe and leave a comment in the chat or a question if you have one to help us with visibility. At this point, no, honestly, my lack of familiarity with Rust has sent me on a rabbit hole, and people are sending me resources now as we speak. But so your issue, as I understand it, is you're getting the raw video data, but it needs to be compiled or encoded or otherwise handled in some way once it gets to the destination, and we're having an issue there somewhere.
Yeah, it's just yes. So the videographed actor is receiving raw video data, And then you have to format it and then create the blocks and the CIDs. And then those CIDs are sent to the
Sent
Waku actor.
Oh, aha. So this is before. Okay, got it.
Yes, so
Okay.
that's the flow, right? That was the part I was a bit confused about.
Okay.
Um, yes. Okay, so now now we have a channel here. It's just called the Waku transmitter, Waku receiver. So the video graph is the Waku transmitter, and Waku handler is receiving the Waku. Maybe it should be the video CID. Yeah, it makes more sense like this. Yes, it's more self-explanatory like this, because otherwise, naming things is a good challenge. But yeah, this is better. So this is raw video. Let's call it raw video. Raw video. So this is the raw video channel. This is the video CID channel, and they both set up in different ways. We have the chat channel too, but that's different. So the raw video transmitter goes where? Oh, here. So that's that's basically the HTTP server that ingests the raw video data. The raw video receiver, that's the video graph here. The video graph is going to receive the raw video, and then it's going to output video CID. And then the video CID is going to go inside of the Waku handler to be published. Yes, that makes sense. Okay. Okay, so everything's hooked up, and the chatter is also hooked to the Waku handler. Yes, chat here. Chat transmitter. Yeah, because Waku handler is receiving chat messages, and it's then using a channel to send the chat messages to the chatter actor for formatting, and not sure what else actually it does. It handles banning your chat account and stuff like this. So it's not just like the chat messages, but more like even the admin messages. Moderation database. Moderation database is disappear ban, stuff like this. Yeah. Anyway, I'm not going to go into that, but that's the responsibility of the chatter actor. So now we should do this for Waku handler, because otherwise it's not going to start. We have to do Waku handler start. It's going to call this. No, this is new. It's going to call this. And then it's going to do the whole life cycle of the Waku actor. And we should be good. Yeah, I think so. Is there anything that looks not great? Hopefully, I did a good job with the errors, so that when we try the CLI, it's going to just tell us what's wrong. So I think we should just try it. So the first thing would be to do a cargo build. Is that the command? Cargo build? Yes, it is. Whoa, we have errors. It's the weird error from last time. So I guess we have to fix that somehow. What does it say? That's really helpful, so maybe we should just try that. But that error is not in our project, which is not good. I think it's a dependency issue, which is not great. It comes from what exactly? Okay, it comes from this screen. To be honest, I have no idea how to fix that. Yes, indeed.
I sense an LLM interaction in our near future.
Yeah, maybe. But I mean, it's an old project, so yeah. It's third ox. Let's check. Okay, so all right. So I'm guessing that all of this is pretty much out of date, but if we we specify the exact version we want to use, maybe it's gonna fix something. I don't see Surday anywhere here, so it's a dependency of a dependency, which is even worse. Well, maybe it comes from clap. Clap is the library used to parse the CLI options and everything. Maybe it's coming from there. I'm not sure. Index.io created. So it's third day ox 4.7. Feature chrono. Which chrono? Is there a chrono somewhere here? No. Huh. Well. What if we do 4.6? Maybe? Oops, 6? Maybe? That's right. Serdi ox. Something like this? No. 8.5? No. 0.8? Oh! Maybe it's not working? Let's try. Oh! No. Okay. Candidate version found which didn't match 7. Okay, so we have 4.7, 4.6, 4.51. 7. Okay. Let's try this one. Oops. This one. What? 4.5.1. Oops. Right? No, it's the same error. Well. maybe it's time to stop because I don't know how to fix this. Or it's gonna take some time probably because dependencies of dependencies. That's kind of hard.
Well, it's
Uh,
a good tease to leave it at,
yeah, I mean,
and we'll get the uh, we'll get the next one on the board
I mean,
and
it's
come back
been
to
45 minutes already, so I guess if people wants to watch me try to debug this for another
it.
15 minutes, but I'm pretty sure no.
So, can you take everyone through what we've come, for those that may have joined in the middle or wherever, what the objective was, what we did in the first session, or what you did in the first session, in the second session now, and then the obstacle that is present, and then we'll look towards maybe later this week or next week to close it out.
Yes. Okay. Um, I guess I should maybe recap everything. So the goal of the two episodes were to replace the PubSub module of IPFS used in this project with Waku. To do that, we had to create a new actor because this project used an actor model as the architecture. We called it Waku Handler. Um, this handler is responsible for setting up the Waku node, uh, registering callbacks, and subscribing to topics, and then also cleaning up after itself, basically. It is listening on the PubSub topic for Waku messages, and it's also publishing uh, messages that it's receiving from somewhere else, and that somewhere else is the other actor in this project, which are the videograph actor, which takes on input raw video data, adds it to IPFS. It creates blocks, and each block has a CID. It then takes the CID, send it to the Waku handler to publish on the PubSub topic. We also have the chatter actor, which receive just the payloads that were contained in the Waku messages that we were listening in the Waku handler actor. And then the same thing, archiving the messages to IPFS and everything. Um, and what else did we do? And the last thing was to set up all the actors so that they work together. So creating the channels to send the Waku messages in between the actors, and the video CIDs and the raw video too, and setting up the Waku handler actor as well. Yeah, that's what we did in 1 hour 45 minutes or so. Yeah.
And all, I should note, without the assistance of a large language model.
Yes. Yeah.
That's raw, uncut fun.
Organic coding.
You could even say it's artisanal.
Yeah.
Well, I appreciate your efforts, SP. I think on Volume 3, Part 3, what saga completes after Part 2? We have to have the third part. The trilogy must be completed, and so it is lining up very nicely. For anyone who wants to learn more about Waku, I implore you to go to waku.org, docs.waku.org. The GitHub repository is waku-org. That is where you will find specs, and of course, all of the repos. We had incredible news last week Safe has implemented, or the news that Safe implemented Waku within Harbor, their new signature handling protocol, I guess, that is in live preview now. This Safe joins Railgun, the Graph, Status, among major projects that do in fact use Waku, and among many others. And the list is growing and it's very exciting. So if this is interesting to you, if private peer-to-peer communications and data transport is interesting to you, I implore you to check out Waku, the greater Logos Network ecosystem. And we'll see you again very, very soon. Follow Waku all over the place, and all the Waku devs and core contributors, which are all devs except for me. I'm the only one
I mean,
who can't code.
you you help the devs.
I try to prop everybody up.
You can't code. That's not true.
Oh, I've been known to put together a heck of a bash script from time to time. I lament that Ruby isn't more relevant. And I just reached out to Afri, who maintains the ETH.RB gem yesterday, actually, and then that prompted me to try to spin up a Rails 8 app for the first time. I haven't done one since Rails 6, and so there was no success. Similar to today's endeavor, it's a to be continued in part 2. But then, and in watching you work with Rust and looking at some of these resources that people have already sent me, I wonder if it wouldn't be more pertinent to put energy behind Rust, and that will sort of backdoor me into understanding what the hell is going on Solana.
Yeah, I think they use Rust exclusively in the WASM modules and things like that. Yeah.
So it might be, I guess. Hey, we can even discuss it now. I in some back channel DMs started stirring up interest for, similar to how we have the IFT NIM club. Perhaps we'd like to do the IFT Rust club, and that's
we have Nomos that's written entirely in Rust.
Well, then I think Alvaro is gonna. I think I'm gonna bother Alvaro, and I haven't gotten to do that in a while, so that'll be
a
fun.
funny thing about Nomos is that the first thing I was looking at their code, and the first thing I noticed is that they built a library in-house for an actor model, just like this project that I was working on before joining. I was like, interesting. It's obviously way more advanced than this is bare bone like actor model. I call it an actor model, but it's just message passing. It's barely an actor model. But what the Nomos team has created, that's proper library for implementing an actor model. So yeah, that was
That's
interesting.
exciting.
Yeah.
Nomos just dropped their white paper, hint, and a light paper, I believe, or if it's maybe that's not public yet, but I'm sure it will be soon. But I think it might be. So I don't know. Hint, everybody. The Nomos white paper is live, and yeah, I think the decision has been made. Man, every year, like twice a year, I come back to Ruby and I go, "What am I gonna do with you in the context of crypto? Like, let's do something." And something else. Oh, I think it was Next.js last time. But it's like, you know what? No, instead, I'm gonna. This time it's Rust. I'm gonna have to name my kid Ruby to keep the name going. That's how it's gonna go. Okay, I've injected Ruby long enough into this. Thank you, SP. We'll see you soon.
Thank you.
Have a great rest of your day, and we'll see you all soon as well. Goodbye, everybody.